Okay, guys, in this video, we are going to take a look at basic derivatives and the ones that you really need to know by heart. This is not something that you can just say, oh, well, I can just look it up in the table or something like that. There is not going to be a table for you. You need to know this stuff. So what I recommend doing is even after you are done with the activity, multiple times come back to this page and practice, practice, practice. The more you practice, the better you're going to be. And really knowing these basic derivatives is going to serve you well for the rest of not just this course, but also other courses, wherever you need calculus. All right, so let's just get started with the first one. So derivative of a number, because it's a number and it doesn't change, remember derivative is the rate of change, is always 0. So as long as this is just a number, and it could be square root of 3, it could be e, it could be pi, doesn't really matter. If it doesn't have the variable with respect to which you're taking the derivative of, whatever that hideous thing could be, it's just going to be always 0. So this is just 0. All right, so the next rule is the power rule, which hopefully everybody knows, but just in case, let's repeat what it says. So power rule says that if you have x to any power, then the way this works is that you're going to take the power and bring it down to the front. So take whatever the power is and put it in front. Okay, so that's step number 1. So that'll be n. Then the power reduces by 1. So you are taking out 1. So n minus 1. Now this works for any n. Doesn't matter if it's positive, negative, fraction, rational number, irrational number, makes no difference. So for something like x to the power 10, this will just become 10, right? Because we bring it the power to the front, and then x to the power 9. Okay, so I just used the power rule straight with n equals 10. Now the next function, the next example, is the most common mistake that I see in my practice of watching what calculus people do, and that is because people remember that, oh yeah, there was an exception where I was supposed to know that derivative of natural log of x, assuming that x is just a positive number, is 1 divided by x. And so they automatically will say, oh yeah, so then if it's 1 over x, that becomes log. Well, no, you can't just swap them and you think that's gonna be the same. That's not true. So how in the world am I supposed to take the derivative of 3 divided by x? It is not going to be natural log of 3x or 3 natural log of x or whatever. That is not correct. So the way you do it, you really memorize it. That's what I would do. So anytime I see derivative of number divided by x, the first thing I need to do is remember that I will have to have a negative sign in the answer. Okay, so that's number 1. Number 2, the x on the bottom will become x to the power 2. Now, word of caution, this will not work if the bottom was like x squared or x cubed or square root of x or whatever. That will not work. It only works when it's just x, okay? So then it becomes x squared, and that whatever number was on the top, that's going to stay the same. So that would be your derivative, okay? So this would be negative 3 divided by x squared. So if you can remember that a divided by x is negative a divided by x squared, when you take the derivative, you're going to be golden, okay? You're going to be good. Now, where does this come from? So let me explain. And really, I would prefer that you memorize it, but if you don't want to, okay, derive it, that's fine, but at least know how to do it. So the way you do it is you think about x as x to the power 1, okay? So what you can do is take this x to the power 1 and move it to the top. And as you move it to the top, by definition of negative powers, this becomes x to the power negative 1, okay? Now, x to the power negative 1 is not already the derivative. All you did is you just rewrote the expression in an equivalent format, but you did not use the power rule yet. So now I use the power rule. So first of all, I also use the constant multiple rule that says that if you have a constant that's multiplied by the function, I need to just keep the constant, okay? Then I'm going to use this rule for n equals negative 1. So I'll bring the negative 1 to the front, and then I have x to the power negative 2. okay? Because when I subtract -1 minus 1, that's -2. All right, now, how do I simplify that? So first, 3 times -1 is -3. Second, the negative power can be moved, like if I make this a fraction and make a 1 on the bottom, if I move it from the top to the bottom, the power becomes positive. So remember, the negative power is really responsible for switching from top to bottom or from bottom to top, wherever it is, okay? So that's where this comes from. So I just didn't want to just spring it on you without any explanation, but if you can memorize this, this is going to serve you well. Okay, the next one, 6 square root of x. Again, I am planning to use regular power rule, and here you can either remember that derivative of square root of x is 1 divided by 2 square roots of x. So if you remember that, then 6 will stay, and it's going to be 2 square root of x on the bottom. Okay, so when you take the derivative of square root of x is 1 over 2 square root of x. Now, I can also simplify 6 and 2, divide by 2, and then that's just going to be 3 over square root of x. Now, why does this happen? So let me show you. Square root is responsible for power 1/2. So when I see square root, that is the same thing as power 1/2. So when I take the derivative, I'm going to move the 1/2 down to the front, and that becomes 1/2 x to the power, and then I have to take away 1. But 1/2 subtract 1 is -1/2. So now we're simplifying that, that's going to become 3x to the power -1/2. So how can I rewrite that? Well, when I see a negative power, so let me make this a fraction, divide by 1, I can just move this to the bottom and it becomes positive. So this becomes 3 divided by x to the power +1/2, which is the same thing as we just talked about as square root of x. So see here, I just memorized what it was. Square root of x is 1 over 2 square roots of x. Here I just showed you why that's the case. So either way, let's put that over here. So this would be 3 divided by square root of x. Okay, how about this next one? So that one is 6 square root of x derivative. But the square root of x now is on the bottom. Okay, so what happens here? Well, you need more rewriting. So number one, remember that square root of x is the same as x to the power 1/2. Number two, before you use the power rule, you want to move this guy from the bottom, because you can't have it on the bottom. You want to move it to the top, and when you do, the power becomes negative. Again, I have not done anything yet. I did not take the derivative. All I did is I just rewrote it in the format convenient to using the power rule. Now I'm going to move the -1/2 to the front and reduce the power by 1. So -1/2 subtract 1, that would be -3/2. And now you could simplify this part as -3, but the rest, you can just leave it like that. If you want to, you can also move it to the bottom. So this could be -3 divided by x to the power 3/2. And if you want to, you can also remember the rules of how you can rewrite it using radicals. That actually will become x to the 1/2 is square root of x. So you can also write it like that even. That would be super fancy. But if you could just do this, that's great. All right, now let's move to trigonometric functions. So one thing that you should remember is that the derivative of sine is cosine. So put it in your bathroom mirror, derivative of sine is cosine. That way you're not going to forget it and you're not going to attach a negative when it doesn't belong anywhere. So derivative of sine is cosine. Okay, so derivative of sine of 3x, how does that work? Well, this is really chain rule, but again, you really need to every time tell yourself, oh, I'm using chain rule. What? Just memorize it, okay? So sine is cosine. It's going to be cosine, but it's going to be the same argument. It's still 3x, so you've had 3x here. It's not going to go anywhere. It's still 3x. And because of chain rule, derivative of this 3x, you have to multiply by it. Okay, which is just going to be 3. So hopefully you remember that derivative of 3x is 3. Because remember, derivative is the slope. And 3x is aligned with the slope of 3. So what is the slope of the line 3x? 3. Okay, so that's it. The next one, so let me just type that here. The next one is the same exact thing, but with cosine. Now, because you promised me that you're going to remember that derivative of sine is cosine, you're going to hopefully also remember that derivative of cosine is negative sine. So if you remember that one of them is negative, but it's not sine, so it's got to be the other one, and that's cosine, so it'll be negative. and this will become sine of 8x. And again, just like before, because of chain rule, there will be 8 in the front. So this is going to become negative 8 sine 8x. Okay, let's move on to natural log and e. All right, so first with natural log. So let's go with natural log. Everyone knows derivative of natural log of x is 1 over x. Now, actually, you can, if x is actually negative, you can put the absolute value here, if that's needed. But if we assume that the variable x is positive, then that's all you need to remember. But how about, what if it's 5x? What do I do with that? Like, where does this 5 come in, right? Okay, so let me explain. So now pretend then this 5x is just like x. So derivative of log of x is 1 over x. So derivative of log of 5x is going to be 1 over 5x, right? However, because of chain rule, derivative of 5x is 5. So there is your 5. And then you can cancel the 5 here. And guess what? You'll get a 1 over x. Actually, here, this is an interesting situation where the 5 just cancels over this. 5x, 10x, whatever. It's just going to be 1 over x anyway, which is kind of interesting. Anyway, now what about e? Okay, so you remember that e to the power x derivative does not change. Hopefully, you will never think that you should use the power rule, like you don't bring x down and reduce the power by 1 or whatever. This is not x to the power something. Power rule is x to the power something that doesn't change. That's for power functions. And e is not a power function, it's an exponential function because the unknown is in the power, okay? So e to the x, you don't use power rule. Well, you should remember that e to the x is one of those things that do not change. So it just keeps staying e to the x, whatever. Okay, but what about if it's e to the 7x? What do I do with that? Well, again, it's the same thing as with the sine and cosine and everything. You pretend like this is like your x. So e to the something is e to the something. But derivative of the something should still be there. So that's going to be 7. Okay, that's going to be in the front. So that's 7 e to the 7x. Another one, by the way, that a lot of students make mistakes on, and so I want to mention that separately. If you have e to the negative x, so people think that the negative just drops out or something. No, it does not. Okay, there's no magic here. E to the something is e to the something. So negative will not gonna go anywhere. It's still gonna be e to the negative x. And then because of chain rule, you multiply by the derivative of negative x, which is negative 1, right? And so you're going to get a negative. And then, oh man, people are like, oh yeah, why don't I just cancel these two minuses? Don't they cancel? I just get e to the x. Well, hopefully you're not going to get that crazy idea to cancel them. And here is something that I recommend doing. If you ever have an itch of doing something not particularly smart, let's just put it this way, and let me simplify it, quote unquote. It's because you have a calculator, why don't you just define two functions? One is going to be the one that you think is correct, and the other one maybe you think, oh, let me cancel it because she told me to cancel or whatever. Plug in any x value in there, okay? Just usually don't want to plug 0, because if you plug 0, it might actually work, and that's going to be kind of sad. So don't do that. Like plug 2 or something. So you will see, oh, whoa, that does not look right. These two are not the same. So I would know, okay, that's not right. Okay, now let's move on to tangent, cotangent, secant, and cosecant. Okay, so these are pure memorization. The fact that there is a number in the front just means that you keep the number. And derivative of tangent x is secant squared x. If you don't remember it, then again, write it on the mirror and better memorize it. Now for cotangent, it's going to be, well, cotangent, cosecant, right? So just remember that both start with a C, and that's going to be negative not secant, cosecant squared x, cosecant squared x. Okay, I got it out of myself. Okay, but so tangent does not change sign, it's secant squared. Cotangent, negative. Okay, what about secant? Secant is secant tangent. So again, this is just pure memorization. So we just add in a 10 at the end. Cosecant, negative cosecant, cotangent. So negative cosecant, cotangent. All right. Finally, this last two, and I was kind of torn on whether to include them or not, because some teachers would put them on their tests, and maybe I'm not going to be one of them, but just in case, again, pure memorization. arc sine x derivative is 1 divided by square root of 1 minus x squared. Can you memorize it? Well, good luck with that. What can I say? So this is going to be square root 1 minus x squared. And then, well, the minus is because there was a minus here. As far as arctangent is the same thing, but there's no square root and there is a plus on the bottom. So that becomes 7 over 1 plus x squared. Okay, let's check this out. So it doesn't like this particular one. So I think I'm gonna need to fix the code. So something is wrong because this is correct. So I'll fix it, but anyway, we are done. So because the answer was correct. Oh, maybe it's negative. Hold on. Because this isn't negative. Oh, Let me check that. Ah, okay. Now we're done.